Welcome to FluidSIM video tutorials. This video describes the search for failures in fluid technology. These are the topics. Overview of failure models in fluid technology. Definition of fluid technical failures. Example hydraulics. Failure simulation, repair mode. Failure simulation. Use of virtual measuring devices. Failure simulation, parameterizable failures. FluidSIM 6 pneumatics contains failure models for configurable directional control valves, throttle check valve, pressure gauge, air filter, maintenance unit, silencer, configurable cylinders and pneumatic lines. FluidSIM 6 hydraulics contains failure models for configurable directional valves, two-way flow control valves, shut-off valve, throttle check valve, pressure relief valves, configurable cylinders and hydraulic lines. These models allow the simulation of circuits with defective assemblies or lines. With virtual measuring devices, failures in fluid power circuits can be localized and corrected in repair mode. Example of a hydraulic drive for lifting and lowering a load. The example is a hydraulic circuit for lifting and lowering loads. The hydraulic cylinder is loaded with a static tensile force of 500 newtons. If the directional control valve SJ1 is in the basic position, the load is lifted. The non-return valve RM1 prevents the fluid from flowing back if there is a power failure in the hydraulic unit. If SJ1 is pressed, the load can be lowered. Failure definition for the example circuit. Failures are defined in expert mode in the ribbon, simulation, with the command, Manage Failure Configuration. With the button, New, a new failure configuration can be created. In the failure configuration dialog, the title and a description are first specified. Both are displayed during the simulation in a yellow title bar above the circuit. The components in which failure is to be installed can be selected from the list of non-defective components. It is recommended to label all components and lines of a circuit. If you check the box, Also list objects without a label, all objects in the list are displayed. Without labeling, it may be difficult to find the desired component in the list. If the component is selected, it appears on the right in the defective components list. The desired failure model is selected in the drop-down box of the failure model column. Some failure models can be set in the parameters column, for example to incorrect hydraulic resistance, internal leakage or an increased coefficient of friction. Now the functionality of the repair mode has to be set. How should the repair success and an incorrect diagnosis be displayed? What repair options are there? Should the line animation be suppressed? With OK, the failure configuration is confirmed. Additional failure configurations can now be created in the management dialog for failure configurations. The order of the failures in the configuration can be changed with the arrows on the right. In addition, failure-free simulation and circuit processing can be inhibited. The failure configuration that is displayed first after loading the circuit in the menu ribbon, Simulation, is selected in the drop-down field, Standard Failure Configuration. Finally, the failure configuration can be protected with a password. Failure simulation, repair mode. Functional failures were defined for a hydraulic lifting cylinder. In the menu ribbon, Simulation, the desired failure model is selected in the drop-down field. If the failure-free simulation is allowed, Learners can simulate the correct function of a circuit. The dash represents the failure-free model. After the start of the simulation in the continuous cycle, the directional control valve is actuated and the process is observed. Failure 1 is then selected in edit mode and the simulation is started. In the example, the load cannot be lowered. The yellow title bar indicates that there is at least one failure in the circuit. Simple failures can also be found without measuring devices. If the Activate Repair Mode button is pressed, the mouse pointer changes to a wrench in the circuit. If the mouse pointer is over a component, the wrench is displayed in a circle. When you click, possible failures in the respective component are displayed. In the example, the hydraulic fluid cannot flow to the tank via the one-way flow control valve and the 4 two-way valve. Since blocked lines are very rare, the cause must be found in the 4 two-way valve or the one-way flow control valve. The check valve is a common cause of failure in throttle check valves. When lowering in this circuit, however, it does not matter whether the non-return valve is defective. The red cross confirms wrong assumptions about failures. It can be displayed permanently or intermittently depending on the failure definition. This leaves the 4 two-way valve as a source of failure. If the valve piston sticks, the valve cannot open. The correctness of the assumption is permanently displayed with a green tick according to the settings in the failure configuration. This eliminates the failure and the circuit works normally. The status is also signaled by the green title bar. Failure simulation. Use of virtual measuring devices. Failure 2 is selected and the simulation started. The function is given, but the lifting cylinder lifts the load much more slowly than with the failure-free shift. In this case, the cause of the failure can only be narrowed down by using virtual measuring devices. The virtual gauges can be activated in the simulation menu in the Virtual Gauges section. There are gauges for pressure, flow, voltage and current. After clicking on the desired measuring device, the crosshairs on the mouse pointer indicate the position of the display of the measured value, which is defined with a mouse click. The probe tips can then be placed on compatible terminals in the circuit. As soon as the measuring tips are placed, the measured value is displayed. If you double-click on the measured value display, you can set the display of the measuring device, as in the example, the flow rate or the total amount that has flowed through. With flow meters, the line is automatically separated and the meter connected in series. The slow stroke movement in the example can be caused by a partial volume flow via the one-way flow control valve and directional control valve to the tank or by internal leakage in the cylinder. A flow meter at connection B of the one-way flow control valve shows that no volume flow can be measured there. A flow meter at the connection of the cylinder shows a volume flow. This means there can only be an internal leak in the cylinder. This can also be verified by measuring the flow on the line between the cylinder and the tank. In repair mode, internal leakage must therefore lead to success. After the repair, the normal function is restored. Failure simulation, parameterizable failures. Failure 2 is a parameterizable failure. The failure configuration for failure 2 shows that the cylinder's failure model, internal leakage, has been selected. The dialog for setting the internal leakage can be opened in the parameter column. In the example, the cylinder has a leakage of 0.04 liters per minute and bar. With a pressure difference of 51.2 bars, the leakage volume flow is 2.048 liters per minute. Failures that can be parameterized are very practical. since failures often occur slowly during operation due to wear, corrosion or other causes. They are the prerequisite for mapping failures that change over time. Thank you for your attention.